In this video, we're going to see how to calculate the molar solubility of a substance using the KSP. In the previous video, we saw how to calculate the KSP using the molar solubility. So KSP is always based off of the molar solubility, which is based off a saturated solution. What that means is that you've dissolved the maximum amount that you can, no less, no more, just the maximum amount. And so here we want to calculate the molar solubility of calcium carbonate. What we're basically saying is how much could you dissolve in a liter of water in terms of moles? How many moles per liter could you dissolve? Another thing that we should mention here is what conditions we're at. And typically when we're doing questions in grade 12, we're usually going to be at SATP unless I tell you otherwise. So we want to find the molar solubility of calcium carbonate. So what we're going to do is we're going to start off by writing a balanced dissociation equation as we've seen in previous videos. And it's going to be in an equilibrium like this. We're going to get the calcium 2 plus ion, there's one, plus the carbonate 2 minus ion, there's one of those, and they're all aqueous because they're surrounded by water. And what we're going to do is we're going to create an ice table. And we can start filling it out. So we know, for example, that over here, we want to get, or over here, we're starting off with 0. If we're starting with pure water, there's no ions there at all. And then we're going to have our plus x, x, and x over here. Over here, in this side, so based on the coefficients, of course, we would have minus x. And remember, the whole point when you're trying to find molar solubility, for example, is that the entire thing will dissolve. All the solid will be gone. So by the end of it, you have 0. So essentially what we're looking for is we're looking for whatever this is over here. And that, remember, is the MSP, which is this value over here, the X value. Now, we're not given any information other than KSP because KSP is based off of the MSP. Now, I know you might be thinking, well, where is KSP here? Well, it's not told to us in the question, but we can go look it up in our table. So we're going to go find the KSP of calcium carbonate in our table over here. Let's scroll down to the KSP values. Calcium carbonate is 3.36 times 10 to the power of negative 9. So the KSP, KSP 3.36 times 10 to the power of negative 9. And this is from our table. So remember, we want to find the X value. So what we can do is we can write a KSP expression. We can say that KSP is equal to the concentration of the calcium ions times the concentration of the carbonate ions. And that's simply X times X, which is X squared. So now we can replace this, plug in all our values. So we know that the 3.36 times 10 to the power of negative 9 is equal to X squared. Therefore, X is going to be equal to square root of the KSP, 3.36 times 10 to the power of negative 9. And that's going to be, so we'll get square root of 3.36 times 10 to the power of negative 9. We get 0.00005795. And don't forget, this is a concentration, moles per liter. Or you could say how many sig figs do we have here? Number of sig figs is, well, we don't have any sig figs given to us because it's our question. So because we're using our KSP, we're going to go with the sig figs of KSP. So about 3 sig figs from the 3.36 from our table. So we'll get about 0.00057 because we want 3 sig figs. That rounds up to 580 moles per liter. So this is the X value that we found. That X value is the MSP, because remember, if we have MSP minus X is equal to 0, well then MSP must be equal to X. So that is the MSP. So therefore, the molar solubility is 0.0000580 moles per liter. You could also write it as this, 5.80 times 10 to the power of negative 5 moles per liter. So in a liter, you could dissolve 5.0 times 10 to the power of negative 5 moles per liter. So what do we do to solve this problem? Well, first of all, we realized that we want to dissolve calcium carbonate, so we wrote a dissociation equation, and we made an ice table, and we set it up. And the question was asking us for the molar solubility. So we're looking for this initial value over here. Essentially, we're looking for our X value. How do we solve for this? Well, we write a KSP expression, and we find the KSP from the table to plug into our KSP expression, which is what we did over here. We then solve for X by doing the square root of our KSP to get the X value, which is our MSP, and then we rounded to 3 significant digits because that is what we had in our KSP value and no other data was given to us. So in this example, we saw how to calculate the MSP using the KSP values. In the next example, we're going to take a look at an effect called the common ion effect.